Sorry guys, we got cut off on the recording because my camera was full. I had to delete some videos. So I just want to catch you up where we were. We were solving for x here, dividing both sides by 3. We got log natural x is less than 8. We wrote this as an exponential so that we could get x alone. So if I look at this, I have x on the left, e to the 8th on the right. Here, x is less than everything else, so here I'm going to keep that symbol. Just to give you a sense, e to the 8th is a really big number. It's about 2,981. And that's fine. I actually plugged in 2,980 and got a true statement, so that was a good check. But this is the other part of the inequality I need to worry about. I can't take the log of a number that's negative or 0. So no matter what x is here, whatever I'm taking the log of or the log natural of, it has to be greater than 0. So I need to build in this x is greater than 0 piece into this compound inequality. So I can actually leave it like this. I can leave e to the 8th, or I could say, it's about 2,981. Either way. So this I'm going to say is a good final answer. Moving on to numbers 11 and 12. For these, I'm asked to decide whether the relationship in the table is linear, exponential, or something else. I'm going to go through these pretty quickly because I feel like these are, we've gotten really used to these. So x goes up by 1, y goes up, it's getting bigger, but by a factor, not by a difference. So I'm not adding a number repeatedly, I'm multiplying by 3 repeatedly. So this is an exponential function. And if it's exponential, you should be able to say what the base is or what the growth rate is. And I'm going to say the growth factor is 3. In other words, I'm multiplying by 3 as I go left to right. So as x goes up by 1 here as well, my y is going up by 4. And this is by a sum or a difference of 4. It's a sum from left to right. It's a difference from right to left. So that is a linear function, and that's because the slope is constant, and the slope is 4 over 1. So as we go up by 1 on the x, we go up by 4 on the y. For number 13, my x's are again going up by 1. That just makes it easy because then we can focus on the y values. My y's are not going up or down consistently. Here we're going down by 3, down by 2, down by 1, up by 0, up by 1, up by 2. So I can see there's a pattern, but it's kind of hard to nail down. So it's not a constant sum or difference. There's definitely not a ratio involved here because it'd have to be constant, and it's not. Like, to get to 9 from 12, I'd have to multiply by 3/4, and that is not how I get to 7 from 9, so that doesn't work. Even though my first difference isn't constant, because I can kind of see a pattern here, I'm going to check on my second difference. So to get from -3 to -2, I add 1. To get from -2 to -1, I add 1. In other words, -2 minus -3 is 1. -1 minus -2 is 1. To get from -1 to 0, I add 1, I add 1, I add 1. So 2 minus 1, 1, 1 minus 0, 1, 0 minus -1, 1. So this is a constant second difference. And we learned in class that when you have a constant second difference, that's a quadratic function. For the last 3 problems, we are writing exponential functions that go through the 2 given points. And these are base functions, meaning there are no horizontal or vertical shifts. Really, all we have is this initial value and the base. So y and x stay y and x in the equation, in the function, and a and b are replaced with constants. So we need to find the growth factor and the initial value. So when we have points that start at 2 and 3, because these are only one x value apart from each other, that makes this really easy. I just need to look and sort of see what times 24 gives me 72. So 72 divided by 24 is 3. So I already know my growth factor is a 3. So in other words, as x gets bigger by 1, y gets bigger by a factor of 3. So that's great. Now I just need to figure out what a is. So I can do that by kind of going backwards to 0 and figuring out what goes here. So I could say, well, what times 3 is 24? 8. What times 3 is 8? 8/3, kind of a yucky number, but it is what it is. So I can do that this way. I can say a times b to the x, and then I can check here y equals, this should be 8/3 times 3 to the x, and I should be able to plug in both numbers and get a true statement here. So if I were to do that, 3 cubed is 27, divided by 3 is 9, times 8, 72. That works. 3 squared is 9, divided by 3 is 3, 3 times 8, 24. That works. So both work. So kind of a gross initial value, but mathematically it works. The other way you could get it besides doing this is to plug in the 3 here, and then just replace these values with the x and y and solve for a. See what a has to be for that to be true. Over here, these numbers have a space between them. They have a 3 between them, so I could kind of make an itty-bitty table if I want. So I have -3, something, -12. So I need to know, what do I multiply by -3 twice to get -12? So to get from -3 to -12, I multiply by 4. So I don't want half of this. I want the square root of this. I want 2. Because times 2 times 2 makes times 4. So this should be a -6. So -3 times 2, -6 times 2, -12. So I know that my growth factor is this. It's the times 2. And then to find my initial value, again, I'm going backwards 2 steps to the 0. I want my y-intercept. So one way I can do it is I can say y equals a times b, which we said is 2 to the x. I can borrow the coordinates of one of these points. So I can borrow the -3y, I can borrow the 2x, and solve for a. So that's 4a equals -3. So a is -3/4, which I would get because this would be -3/2 divided by -2 is -3/4, or divided by +2 as we go to the left. So my equation here is y equals -3/4 times 2 to the x. And this is what allows all of my outputs to be negative numbers. So for this last question, we are writing a function that models the data in the table. Again, we're going to sort of keep it simple and use this y equals a times b to the x form. And I need to do 2 things. I need to find my initial value, and I also need to find my growth factor here. So this can get a little gnarly because here I'm counting by 2s. I'm not going up by 1. But what I could do to find the initial value is just kind of like go backwards once, and that's going to make this really easy. So if I want to find what do I multiply by to get from here to here, it's kind of a yucky number. I'm actually going to look at this as a division instead. So what do I divide 5.6 by to get 3.2? And that's a 1.75. So in other words, 5.6 divided by 1.75 gives me 3.2. So I divided 5.6 by 3.2 and got 1.75. When I did it the other way, I got a really, really uncomfortable repeating decimal, and that would have expressed it as a multiplication, but either way I can use this as my pattern. So if I want to go this direction, I just multiply by 1.75. So I take 5.6 and I'm going to multiply by 1.75, and I'm going to get 9.8. And that makes sense because these numbers are getting smaller from right to left, okay? So my A value is 9.8. Now my B value is whatever I multiply to this to get this, okay? Actually, to get what's between these two, right? So that's a little bit tougher because it's going to be the square root of whatever's between these two. So that might not come out to be really pretty. So I'm going to say 3.2 to 1.8. So what do I multiply to 3.2 to get 1.8 is going to be this number here, okay? And that is about, let's see, 1.8 divided by 3.2 And again, these numbers are not totally perfect, but we're going to get about 0.5625. And then I'm going to take the square root of that number. So the square root of 0.5625 is 0.75. So in other words, to get from here to here, I'm multiplying by 0.75 about. So I could look from, least to greatest or just pick two numbers. At this point in this lesson, honestly, I'm fine with just you picking two numbers and finding that rate of change there. So that's going to be my B value. So my B value is 0.75 or 3/4. So that is going to be your equation. And if we want to find what 12 is going to be, I can just take this number, the 0.6, and multiply it by 0.75, and I'm going to get about 0.45. So that's the output when the input is 12.